Hello guys, so today I'll be explaining the math course practice, not the course practice, sorry, the grids and the top questions, okay? So, let's start. What is the value of x? By looking at this, you will see that they're both intercepting the same arc. If they're both intercepting the same arc, then that makes them equal, so 6x is equal to 48, x is then equal to 8. Now we have grid number 20, I believe. Here we go. So now, in the figure below, line A is tangent to the circle at H and forms an angle of measure 79 degrees with HG. By looking at this, you will notice what? You will notice that this arc in blue, HG, is intercepted by this angle over here. So that means the measure of this arc is going to be 79 times 2. But if you look really closely, you will notice that this inscribed angle as well intercepts the very same arc. So also the value of this arc will be 79 times 2. So very simply, we can say that the angle x is equal to the angle h. So the value of x is 79. Again, because they're both intercepting the same arc, you notice they're both intercepting the same arc, so that means they are equal to each other. 21. So, in the figure below, the measure of arc WU is 50 degrees, while the measure of FV is x degrees. Now, if you remember in the quiz, I explained how to do this. The middle angle, so I will say M angle, is equal to arc 1, so A1 plus arc 2, A2, divided by 2. So again, anytime we see a figure like this, the middle angle is equal to arc 1 plus arc 2 divided by 2. So let's substitute. 70 degrees is equal to the arc 1, which is 50, plus the arc 2, which is x divided by 2. 70 times 2 is 140, so 140 is equal to 50 plus x. So then bring 50 to the other side. 140 minus 50 is equal to x. X is then equal to 90. So that was it for grid 21. Now grid 23. In the figure below, S is tangent to the circle at R. The measure of the angle is formed by S, and segment MR is x degrees. They need us to find the value of x. If you notice, x is intercepting this arc over here. And if you notice, this angle over here is also intercepting the very same arc. So if we find this angle over here, then we would have found x. Notice it is an isosceles triangle. Isosceles triangle means the base angles are equal, so we can call this y, and this will also be y. In a triangle, we know that the total measure is 180, so 52 plus y is equal to 180. Move 52 to the other side, 2y is equal to 180 minus 52. We need to practice to do it without calculators, because in math we're not allowed to use calculators. So 180 minus 52. 10 minus 2 is 8, and then 17 minus 5 is 12, so 128. So 2y is equal to 128, so then y is equal to 64. So now we have the value of y, which is 64. And we said if we find the value of this angle over here, then we would have gotten what? This angle over here. So that means the angle x is equal to 64 degrees. Now, grid number 27. Okay. A, B, C, and D are points on the circumference of the circle with center O. AOC is a straight line and measure angle BDA is 44 degrees. Find the measure of BAC. Very simply, we use our given. We know that AOC is a straight line. So if it's a straight line, that means its measure is 180. صح? But we also notice what? It is a straight line passing through the diameter. So, passing through the center. So if it's 2 points on the circle passing through the diameter, then it is what? It is passing through the center, then it is a diameter. So if this is a diameter, then we know directly this angle over here is 90. Okay, and this angle over here is 44. It intercepts this arc. This angle over here also intercepts the same arc. So if this is 44, then this angle also over here is 44. So very easily we can find the measure of angle BAC. You can either do 180 minus 90 plus 44, or you can know directly 180 minus 90 is 90, and then 90 minus 44, let's do it here, 10 minus 4 is 6, this becomes 8, 46. So the measure of angle BAC is 46 degrees. Now we have also grid 31. Here we go. So I explained it in a different method in the quiz. My teacher explained to me another method, which I believe is much easier. So directly we see we have a central angle over here, which is 128. They need the angle of what? They need the angle of ADB. They need this one over here. But we notice that we have a central angle over here, and it's intercepting this arc in pink. But we notice that we have an interior angle that's also intercepting the same arc. So the rule is that interior angle is equal to the measure of the arc divided by 2, and we know that central is equal to the measure of the arc. So if we have the central angle, which is 128, we can simply replace it in the measure of the arc. So now to find the interior angle is equal to the measure of the arc, which is the central angle, which is 128, divided by 2. So then the interior is 64. So it is 64 over here. Now if you notice, in green we have what? We have a cyclic quadrilateral, meaning that opposite angles are supplementary. That means 64 plus measure of angle ADB is equal to 180. Very easily we move 64 to the other side. 180 minus 64 is 7, 11. So then we get the measure of angle ADB is 116 degrees. So that was grid 31. Now I believe we have top question. So we're gonna start with top question 34. A very important question. They're telling us to find the angle of BCD by looking, which angle do they need? They need BCD. I can tell you something really easily. You have a cyclic quadrilateral, and we remember that the rule in a cyclic quadrilateral, and we also have an exterior angle, by the way, the rule between a cyclic quadrilateral and an exterior angle is that exterior angle is equal to the opposite of the interior only in the case of a cyclic quadrilateral. Okay? So we're looking for angle BCD, which is this angle over here. If you notice, we have this angle over here. So we have an exterior angle. This is its interior. And what's the opposite of its interior? It is the angle BCD. So applying this rule, we know that 81 is equal to the opposite of its interior, which is measure angle BCD. So the angle BCD is 81 degrees. Okay? Now, angle CD, angle CDB. So very simply, what I'm gonna do is I'm gonna take another triangle in red. Okay, this triangle over here. We have this angle over here, which is 25 degrees. Okay, we can find this angle over here. How? We know that this is a straight line. So if it's a straight line, then if we find this angle, we can do 180 minus the angle in blue, and we found this angle over here. Meaning, we can find, first of all, angle ABE. Measure of angle ABE is equal to 180 minus 30 plus 81. So if we do it, 180 minus 30 plus 81, 30 plus 81 is 111, so 180 minus 111, this becomes 10, this becomes 7, so 6 here, and then 9, 69. So now we have that this angle over here is 69 degrees. So very simply we can what? We can find this angle over here in red by doing 180 minus 69. 10 minus 9 is 1, 7, 11, so 111. So this angle over here is 111. So now we have two angles in this triangle. Will we be able to find the third? Most definitely. We can do 180 minus 111 plus 25. This I believe becomes 180 minus 136. Then this is 10, this is 7. So then we will get an answer of 44 degrees. So now look at this. We have this angle over here which is 81 degrees and this angle over here which is 44 degrees. And also let's not forget this angle over here that we found to be 69 degrees and this angle over here which is 111 degrees. So then we're gonna go back to the original point. They need the angle CDB. But why did you do all this long step, Amanda? Because look, if you notice, they both intercept the same arc. So, since they both intercept the same arc, we can very simply say that angle CDB is equal to angle 44 degrees. So if this one was 81, then this one is 44 degrees. And now finally they need the angle CDE. If you notice again, we have the same logic as part A, where the exterior angle is equal to the opposite of interior in the cyclic quadrilateral. So this is the exterior angle of this over here, and the opposite angle is CDE. So very simply, the exterior angle, which is 69 degrees, is equal to the opposite of the interior, which is angle CDE. So angle CDE is equal to 69 degrees. So that is it for question number 34. Now 35. So now AD is a diameter of the circle and CD is parallel to AE. Find the values of X, Y, W, and Z and give a reason for each answer. So we need to find X, Y, W, and Z. Okay? So very easily, we have to have a quick eye when we're doing this, okay? You can see that angle X and this over here intercept the same arc. So they're both inscribed angles and they're both intercepting the same arc. This one is 20 degrees, so that's definitely this one will be 20 degrees. Now, why? I think they told us AD is a diameter, صح? So AD is a diameter. If we're gonna take this triangle over here, it's gonna be what? A right triangle. So this is 90 degrees. So we have 90 degrees, we have 54 degrees. So definitely we can find Y degrees. So now Y is equal to 180 minus 90 plus 54. So Y is equal to 90 minus 54. Let's do it here. I believe it is 36. So angle Y is 36 degrees. Now we are looking at what? At angle W. So can I erase this? No, I'm not able to. So let me just like undo these. 1 second. So now we got that Y was 36 degrees. Now angle W. To find angle W, actually, if you notice something, I don't know if you guys noticed, but I noticed that if you take this, it will intercept all of this arc in green. And if you take this, it's also intercepting the very same arc. So we can say that W plus 20 is equal to 54. Move 20 to the other side, so W is then equal to 34 degrees. Now finally, we need to find angle Z. It was given to us what? That CD and AE are parallel. So definitely when we have parallel, we're going to have alternate interior angles. So angle Z is going to be equal to angle W plus 20. We know W is 34, so Z is equal to 34 plus 20, which is then 54 degrees. So that was it for top question number 35. Now we have section 4. And then here we have grid 39. This is basically one of the easiest ones. We have a tangent and a secant. Whenever we have a tangent and a secant, the rule is tangent squared is equal to exterior times all. So our tangent is x. So x squared is equal to the exterior, which is 10, multiplied by all, which is 10 plus 30, which is 40. So x squared is equal to 400. And we should know that if you do radical on both sides, x will be equal to 20. So that was it for grid number 39, or question number 39 grid. Now I'm gonna be looking for some tops. Yeah, we have a top over here. Okay, so we have KL and KP are tangents to circle O, and measure angle MON is 100 degrees. So over here this is 100 degrees. Okay, they need us to find the measure of the angle MNL. Very simply by looking at it. Okay, we will notice that we have what? We have a diameter. So a diameter, the inscribed angle of a diameter is 90 degrees. So we have a right angle over here. And to find this angle over here is very simple actually. This is an isosceles triangle because the radii are equal. This side is equal to this side. So this angle will be equal to this angle over here. We can call this y, we can call this y. So now 100 plus y is equal to 180. 100 plus 2y is equal to 180. Move this to the other side. 2y is gonna be equal to 80, so y is equal to 40. So now we have that this over here is 40 and this over here is 40. Okay, so now we have what? We have a 90 degree and we have a 40 degree. We can directly find the measure of MNL, which is 40 degrees. So now we have that MNL is 40 degrees. They're asking now for what? For the measure of angle MLQ. My bad, MLQ looks like this. The measure of angle MLQ. What a nice question. We know that this is 100, صح? And since this is a diameter is a straight line. So definitely, if this is a straight line, then its degrees is 80. So this angle over here is gonna be 180 minus 100, which is 80. And so we have a central angle over here, which is 80, and we have an inscribed angle. If you remember the relation between inscribed or interior angle, it is the measure of the arc over 2, and then the central angle, which is the measure of the arc. To find the inscribed angle, very simply, we are gonna do inscribed is equal to the measure of the arc, which is the central angle, which is 80 divided by 2. So then it is 40 degrees. So again, we have 40 degrees and 40 degrees. Now measure MLN. Sorry, my drawing's not the best. I can't even trace properly. Okay, MLN. We know this was 90 degrees and we know this is 40 degrees. So this is really easy to find MLN. Just do 90 or 180 minus 90 plus 40 and you will get 50 degrees. Now they need the measure of LNP. So this is LNP. We know that this angle over here is 80 degrees. And since they are vertical angles, this over here will also be 80 degrees. And we know that this side is equal to this side because the radii in a circle are equal. So then, finally, we can find the measure of this. Let's call this x. So 80 plus x is equal to 180. 2x is equal to 180 minus 80, which is 100, so x is equal to 50 degrees. So we found the measure of LNP, which is 50 degrees. Now, we have two tangents. Definitely the two tangents of the same circle are going to be equal. So if KP is 20, then KL is also 20. So KP equal KL equal 20. That was it for top number 45. Now top number 46. Okay, so now question number 46. The straight lines AD and BC intersect at O. AB is parallel to CD. Okay, and measure angle ODC is 36 degrees. So they want us to find the value of y. Since they are parallel, they form alternate interior angles. So y is equal to 36. So yeah, y is 36 degrees. Now they're telling us if AB is 10, CD is 4, AO is 8, they're telling us to find the value of OD. Let me call it x, okay? Very simply, we're going to use the proportionality theorem. So we're going to do this side over this side since they're parallel. So 10 over 4 is equal to this part since it belongs to the 10. So 8 over x. So then we're going to do cross multiplication. 10x is equal to 32. So then x is equal to 3.2. So the value of OD is 3.2. So that is part A done. Now part B. The diagram below shows a point ABC. The diagram below shows points A, B, C, and D on the circumference of a circle with center O. So AB is equal to BC and OBC is 28 degrees. What we can do directly is that we can take this big triangle over here, okay? Or actually before that, look at this. We can take this triangle over here in red and this triangle over here in blue. So it's given that this side is equal to this side and these sides are congruent because they are like the same side, the reflexive side, and this is congruent because they are both radii. So these are two congruent triangles. So that means if this is 28 degrees, then this is definitely 28 degrees. So yani, the full angle became 56 degrees. Now, if you notice, it is intercepting which arc? It's intercepting this arc over here. So very simply, we can do 56 times 2, which is 112. So the measure of this arc over here is 112. So now, this is the important part. To find the measure of all of this arc, it's 360 minus 112, which is 8, 4, and then 148. Actually, my bad, that's a calculation mistake from me. Over here is 248. So I really apologize for the calculation mistake. So anyways, it's 248. Or actually, wait, there's an easier way, a very much easier way. So look at this. We got that this is 112, صح? And this is a diameter, so all of this arc is how much? 180, okay? So 180 minus 112, we are gonna get 68. So now we have the measure of this arc is 68 degrees. So now they need what? They need the measure of the angle COD. So COD is an inscribed angle, sorry, not an inscribed angle, a central angle. So we know that the rule of the central angle is that central angle is equal to the measure of the arc. So if the arc is 68 degrees, then the measure of the central angle is 68 degrees. Now we have part C. Part C is very nice actually. So we need to find first the measure of the angles ABD and ACD. Very simply, because they are angles that intercept the arc of 180 degrees, they are both 90 degrees. Okay. Now we need to find the angle CAD. Okay? We have this angle over here is 40 degrees, but we need to find this angle over here. If you notice, it intercepts the same arc that FAB intercepts. So that means it's 25 degrees. So we have that this is 25 degrees. Very simply, we can find the angle CAD. So it's gonna be 90 minus this angle over here, which is 40 plus 25. So if we do this, it is gonna be 25 degrees. So CAD is 25 degrees. Now determine the nature of quadrilateral ABC. D, it is a trapezoid, so you can just say a trapezoid or a cyclic trapezoid. So yeah, it's correct. So that is question 46 done. Now question 47. I think it's a relatively easy question. Part A, we need to find the values of x, y, and z. X is over here. First thing, we notice that this is parallel to this. So if this is 130, then definitely this over here is 130. And x and 130 are supplementary. So we can find x by doing 180 minus 130, and we will get 50 degrees. Now to find y is very easy because this is like a z shape, if you notice. So they're alternate in their angles. So we get that y is 62 degrees. So first of all, x is 50, y is 62. And now finally, to get z, we can do 180 minus 62 because they are on the same line. So 180 minus 62 minus 2, 8, 7, 118. So z is 118. Now let's go to part B. Consider the diagram below. They told us find the measure of A, C, B. Okay, very easy. First thing we can do is that we can consider, since it is an isosceles triangle, that if this is 30 degrees, then these two are what, the base angle, so they're equal. So let's say this is y and this is y. So 30 plus y is equal to 180. Move it to the other side. 2y is equal to 150. Y is equal to 75. So now the base angle is 75 degrees. And definitely, since angle A and angle B, they intercept the same arc, they're gonna be equal. So over here, this is 30 degrees. And actually, to be honest, look, they told us AC is a diameter. That means what? That means this over here is 90 degrees. So if this is 30 and this is 90, this leaves us with 60 degrees over here. And we know what? We know that all of this is 75 degrees. So 75 minus 60, we get the angle of ACB, which is 15 degrees. Now, part C. Okay, now part C. The points K and M and N lie on the circumference, blah, blah, blah. We have K and M is 112 degrees. They need us to find the value of what? KOM. Very simply, we know that this is a cyclic quadrilateral, and we know that opposite sides in a cyclic quadrilateral are supplementary. So we do 180 minus 112. This becomes 6, 8, 5. Sorry, I did calculation mistake again. 6. So that we get that this angle over here is 68, but we know that the angle KOM that we're looking for is a central angle, whereas we have an inscribed angle that intercepts the same arc as KOM, okay, and it is 68. We know that the rule for inscribed angle is the measure of the arc over 2, and the rule of the central angle is that it's equal to the measure of the arc. So the inscribed, which is 68, times 2 is equal to the measure of the arc. 68 times 2, 136. So now the measure of the arc is 136, so it's equal to the central angle. So since KOM is the central angle, then its measure is 136 degrees. Now that was top 47. We still have top 48, top 49. Then the stat questions and we're done. Okay? So we need to find what? We need to find the measure of angle CAD. Where's CAD? This is CAD. So to find the angle CAD, we notice it's inscribing what? This arc over here. And if we pay attention, also the triangle COD is also intercepting the very same arc. So you can say that since COD is the central angle, we can say then it is equal to the measure of the angle CAD times 2. So easily we can find the measure of COD because it's an isosceles triangle, so this over here is 41. Then to find the measurement, we're gonna do 180 minus 41 plus 41. So I use the calculator for this, don't do it guys. 98, okay? So the measure of COD is 98. It is equal to 2 times the measure of CAD. So divide both sides by 2, you get that the angle of CAD is equal to 98 divided by 2, which is 49. So over here, this is 49 degrees. Now, CED, they need what? CED. Since they are inscribing the same angle as, same arc as CAD, then the measure of CED is equal to the measure of CAD, which is 49. Now they want us to find the measure of the angle EDO. Actually, it's very simple. So we have that this is a cyclic quadrilateral. So 84 plus this angle over here is 180. So 84 plus 41 plus 23 plus the angle that I will call X, which is EOD, or EDO, sorry, okay, is equal to 180. So I'll use the calculator to be a little faster. Do not use it, guys. Please do it on paper. We will get that the angle X, or the angle EDO, 32 degrees. So that was for top number 48. Now part B. In a regular polygon, the interior angle is 11 times the exterior angle. I do not think this is coming, so I'm gonna skip part B because it's about something we did in grade 7. So now we have 2 more questions and then we will go to the grid. So okay, so also this is the same as the one up, we don't have it. So let's do part B. Refer to the diagram below. We need to find the value of X. This is a very, very simple question. We know that the measure of angle KOM is X. So they're saying over here, they drew it for us is X degrees. So over here is what? 360 minus X, because it makes a circle, okay? So now we have a central angle and an interior angle. The relation between interior and central is that interior times 2 or interior is equal to central divided by 2. So the interior angle, which we have as 0.25x minus 10.5, is equal to the central, which is 360 minus x divided by 2. So multiply all of this by 2, you will get 0.5x minus 21 is equal to 360 minus x. Bring this to here, bring this to there. Now you will get 1.5x is equal to 360 plus 21. I will do it on the calculator to be fast. 381. So now 381 divided by 1.5, we will get that x is what? 254. So this is done. Now we reach the SAT questions. These might be coming based on my teacher. So I'm just gonna explain this one. Basically, what they told us is that if you extend the ladder, it will complete it all. Okay? So all of it in blue is L, and then they told us they extended it a distance of 1.6 meters. So over here it's 1.6 meters. So then we do Pythagorean theorem, which is L minus 1.6 squared plus 4.8 squared is equal to L squared. Then we solve, we get L squared minus 3.2L plus 2.56 plus 4.8 squared plus 23.04 is equal to L squared. Cross this, move this to the other side. So now 2.56 plus 23.04 becomes 25.6 is equal to 3.2L. Then divide both sides by 3.2 and we will get that L is equal to 8. Now over here, actually, to be honest, this and this are really easy, so I'll let you guys do it by yourselves. So thank you guys for watching. I hope you understood, and do well in your exam tomorrow.